What's up, everyone? Today we're going to talk about our final hypothesis test, which is the t-test. So let's get into it. So a little bit of information about the t-test before we actually do it. It can be used for two sets of data that are measuring the same thing. It only applies to normally distributed data, which we'll talk more about in our last unit, but as a reminder, that's the bell curve that we're looking at. It compares the two means, or the means of the two sets of data. And it can be carried out in the calculator, which the directions to that are linked on that slide. How to perform the t-test, just like the chi-square tests we've been talking about, is you have to first state two hypotheses. Your null hypothesis is that the two means are equal to each other. So the mean of data set 1 is equal to the mean of data set 2. Your alternative hypothesis is that the two means are not equal to each other, but there's two different ways we can say that. If you're looking just that they are not equal to each other, you're not being specific at all. That's called a two-tailed test, and you would just take your null hypothesis and stick that word not in there. The mean of data set number 1 is not equal to the mean of data set number 2. Some problems get a little more specific, where they say they're looking to see if one mean is greater than the other mean, and that's called a one-tailed test. So it could be that the mean of data set number 1 is greater than the mean of data set number 2, or vice versa. Once you have your hypotheses set up, you'll use your graphing display calculator to find the t statistic and the p-value, or the t-value and the p-value. For exam purposes, we're only going to use the p-value to make our conclusion in step number 4. Well, we'll compare that p-value to the significance level, which again will be given to you in the problem. And it's just like our chi-squared tests, that if the p-value is greater than the significance level, we accept the null hypothesis, versus if it's less than the significance level, we'll reject it. So let's get into an example here. In example 1, Maisie noticed that the sun shines more on one side of her garden than the other. She wanted to know whether this had any effect on the heights of the tulips on either side of the garden, and the data is shown in this table. So we had one long table, so we split it up into two parts. In column number 1, on both pieces, is the length of the tulips on the right side, and then in column number 2, on both pieces, is the length of the tulips on the left side. And in part A, we're asked to write down the null and alternative hypotheses. So again, my null hypothesis is always just that the two means of my data sets are equal to each other, but you always want to tie that back to the actual problem. You don't want to just say mean 1 equals mean 2. Provide some detail from the actual problem. So for example, my null hypothesis is that the mean of the tulips on the left side is equal to the mean of the tulips on the right side. For our alternative hypothesis, Maisie was just wondering if the amount of sun had any effect on the length of her tulips. So she's not claiming that one side is going to be more than the other. And because she's not claiming that, my alternative hypothesis is just going to be that the means are not equal to each other. So our alternative hypothesis, the mean of the tulips on the left side is not equal to the mean of the tulips on the right side, which means I'm looking at a two-tailed test. Example 1 continued, we're finding the t-value and the p-value for a t-test at the 5% significance level. So this is where my calculator comes in. In my calculator, I'm following those same steps that were linked in a couple of slides beforehand. So you can read them there as well while I do them. First, I put in all of my data into two lists. So I put the tulips on the right side in L1 and the left side in L2, just because that's how it was given to me in the table. Once you have all of your data in your list, you'll go to Stat and over to Calc, and we're always going to choose the two sample t-test because we have two different samplings that we're looking at. So in here, you got a lot of different options, most of which are going to remain unchanged. So my input is going to be data because I have data as my input. Depending on where you put your data, my data is in L1 and L2. So my list 1 and list 2 will remain the same. Frequency 1 and 2, we're always just going to leave at 1, whatever it is as is the default. This line with the U1 is where things might change. So this is setting up what was your null hypothesis and your alternative hypothesis. What are you testing here? We were testing that for our alternative hypothesis, that U1 is not equal to U2, meaning the means are not equal to each other. Versus if I wanted to say U2 is larger or U1 is larger, I could choose the other options. But for our alternative hypothesis, it's that they're not equal to each other. The pooled line will always be automatically defaulted to no, but we want to change it to yes. And we're saying yes because we're assuming that this data is normally distributed. So we're going to say yes to pooling. Color doesn't matter because we're just going to go down to calculate. And the values that we need are right up at the top. My t value is this negative 3.0722, etc. And my p-value is 0.003916, blah, blah, blah. So we'll round both of them to 3 significant figures. All right, and then finally, part C, writing down the conclusion to the test. Again, we're only going to be using the p-value to make these conclusions because they're going to be giving us the significance level versus they're not going to give us anything to compare the t-value with. So comparing my p-value with my significance level, again, changing that percent to a decimal, 0.0392 is less than 0.05, so therefore I am rejecting my null hypothesis. And since my null hypothesis is rejected, I could even go a little bit further and say there is a difference between the heights of the tulips on either side. So in terms of like, what do you need to say? This is really our final answer here, right? That the null hypothesis is rejected. This piece is your work. That's your work to back up why you're rejecting the null hypothesis. And then this sentence is just a little bit extra in terms of what does it mean that the null hypothesis is rejected? You're reminding the reader what the null hypothesis was and what the actual conclusion is. Let's try one more. Example 2. An oil company claims to have developed a fuel that will increase the distance traveled for every liter of fuel. 10 scooters are filled with 1 liter of normal fuel and 10 are filled with 1 liter of new fuel. The distance in kilometers traveled on that 1 liter by each scooter are as follows. Oh my gosh. So we got the original fuel on the top and the new fuel on the bottom. So these numbers are representing how far those scooters traveled, each of those 10 scooters traveled. And then letter A, again, asks us to write down the null and alternative hypotheses. So my null, again, is just always that they are going to be equal to each other. The mean of the distance traveled on the original fuel is going to be equal to the mean of the distance traveled on the new fuel. You could also say, it doesn't have to be the exact same wording every time. You could also say the average distance traveled with both fuels is the same, because that's saying the same thing. For my alternative hypothesis, I want to go back and read the first sentence. An oil company claims to have developed a fuel that will increase the distance traveled for every liter of fuel. So they're claiming that this new fuel is going to be able to allow you to travel a greater distance. So instead of saying just that the two means are not equal to each other, they're making a specific claim here that this new fuel will be greater or allow a greater distance traveled than the original fuel. So that's what I have to say in my alternative hypothesis. You could also say that the distance traveled with the original fuel is less than the distance traveled with the new fuel. And I only flipped it around just because of how the directions were set up for us, that it usually puts the list 1 first and then list 2. Example 2 continued. We're again asked to find the t-value and the p-value for a t-test at the 5% significance level. So again, I'll go to my calculator. In stat edit into my list, I already have all my information. I put my original fuel in L1 and the new fuel in L2. So now I can run my t-test. Going to stat, test, to sample t-test. My data remains the same, L1, L2, 1, 1. The only thing I'm going to change is this line, U1. We had said that U1 should be less than U2. My original fuel will allow for less distance traveled than my new fuel. So I'm going to have to change that. Still pooled and down to calculate. So my t value is a negative 2.83 rounded to 3 significant figures, and my p value is a 0.00561 rounded to 3 significant figures. Finally, writing the conclusion for the test, again, I'll compare my p-value to my significance level, so 0.00561, compared to my 5% as a decimal, so 0.05. 0.00561 is less than my 0.05. So again, our null hypothesis is rejected. And again, I can add a little bit of extra in there and say that the company's claim was correct, since they were claiming that that new fuel would allow for longer distance traveled.